Okay, listen dear all students carefully. The next new chapter is thermodynamics. Okay, thermodynamics chapter. Now, what is the meaning of thermodynamics? Thermodynamics means it mainly the meaning of thermodynamics is the flow of heat. It indicates the flow of heat. So thermodynamics, it is the one branch of science only. Okay, thermodynamics as nowadays very important. So this thermodynamics mainly explains or deals with the energy changes, in a physical and chemical changes, or physical and chemical process, or physical and chemical reactions. So thermodynamics will explains the chemical changes during the physical reactions or as well as in chemical reactions is called as a thermodynamics. Okay students, now in this thermodynamics chapter, before discussing the main important concepts in thermodynamics chapter, first what are the important terms we are using in this thermodynamics chapter? Those are all terms we need to discuss. From these terms and important concepts, compulsory they are asking in NEET and JEE examination. Previously they are asked NEET and JEE examination questions from the terms used in thermodynamics. Terms used in thermodynamics from the concept also in NEET and JEE examination, direct theoretical bits they are asked, and board examination compulsory one question guarantee the terms used in thermodynamics. Let's see terms used in thermodynamics. First one is thermodynamics system. What is system? System is nothing but it is a small portion in the universe. For example, you have to think about our college only. If college is a complete one universe, if you are thinking in that your classroom, first PUC classroom is a small part. That small part in the universe is called as a system. Small part in the universe is called a system. Okay. So the small part in the system is called a universe. Small part in universe is called as a system. Now, and what about surroundings? Surroundings means except system, the remaining part in the universe. The remaining part in the universe is called as a surroundings. Is called as surroundings. For example, I said already, college. If you are taking completely, it is one universe. That one classroom is a small part. It is called a system. You are thinking one classroom is system. The remaining part is surroundings. Then total system plus surroundings is called universe. The system plus surroundings is called as a universe. System and the surroundings are called as universe. So the system means small part in the universe, small portion or small part. The remaining part, except system, the remaining part is called surroundings. Remaining part is called surroundings, and system plus surroundings is equal to universe. Means if you are thinking your college is a universe, means that college building is a universe. In that your first PUC classroom is one small part, it is system. The remaining part is a surroundings. So system plus surroundings is equal to universe. Okay, now boundary. What is boundary? Boundary means system and surroundings total. You think it is a universe, it is a universe. In that small part, this is a small part. The small part is called a system. Small part is called system. Then remaining part is surroundings. Remaining part. What is surroundings. Okay students, now this boundary means it is a line, means interface. It may be real or imaginary. Means boundary means what, ma'am? System and surroundings both are separated by a small portion. It may be real or imaginary. That small portion or small interface or barrier is known as a boundary. It is called a boundary. Boundary. For example, in your classroom can be separated from the entire college by walls. That is real boundary. Sometimes in a chemical reactions, maybe boundaries, maybe real boundaries are present or imaginary boundaries also be present. So the boundary means it is a real or imaginary object. It separates, the boundary mainly separates system and surroundings. So what is the importance of this boundary? Through this boundary, energy and mass are transferred between the system and surroundings. So energy and mass, that main importance of this boundary is it helps to transfer energy and mass or matter will be transferred between the system and surroundings through boundary. That boundary may be a real or a imaginary interface. Okay, students. So the important terms in thermodynamics, first one is system, surroundings. System plus surroundings is equal to universe, and system and surroundings both are separated by a real or imaginary interface is known as boundary. So what is the importance of the boundary? Boundary will helps to transfer the transformation of energy and mass between the system and surroundings. Means either energy will be transferred from system to surrounding or surrounding to system, or mass also will be transferred between the system and surroundings. Okay, students, let's listen carefully. Next, types of systems. Listen carefully, types of system. So the first classification, types of system based on the interaction between system and surroundings. Systems are classified into three types. Based on the interaction with the surroundings, systems are classified into how many types, dear students? Three types. One is open system, the second one is closed system, the third one is isolated system. Open, closed and isolated. So this classification is mainly that it by using the interaction between system and surroundings. The systems are classified into three types. One is open, closed and isolated. Isolated systems. Okay, now what is the meaning of open system? Open system means, for example, you have to take one teacup, like it is a open system. In the teacup you have to take tea. Tea means hot, very hot condition. Like you have to take in a beaker hot water, hot tea or water is present. In this case, this open beaker, open vessel or open beaker. Now, in this case, if in that open beaker, if you are taking hot water, then what happens after some time? Hot water means the water vapors will be exchanged from the system to surroundings. This is the system. This cup is system, the remaining is surroundings. So the energy and mass, both, mass means matter, energy as well as matter or mass, both will be exchanged between the system and surroundings. System to surroundings, the energy as well as mass both will be exchanged from system to surroundings. Such type of systems are called as open systems. Open system example, hot water in open vessel, or all living beings. All living things means human beings also living things only. In our body is a open system only, is not a closed system. If you are observed that our body have to run fast, then what happens after sometimes our body becomes very hot. And if you are observed that after running, our body becomes very hot. After 5 to 10 minutes, again it becomes very cool and it releases energy, as well as from our body some sweat will comes outside, water will comes outside, and energy also it will releases. That's why our body is also example for open system only, and hot water is present in a open beaker or open vessel. The example for open system. So in open system, energy as well as mass or matter exchanges from system to surroundings, exchanges from system to surroundings. Okay students, let's see the second one is a closed system. Closed system means what? Only means you have to take one closed beaker, closed beaker, closed. In this closed beaker, just you have to take hot water, hot water. If you are taking hot water, then it becomes water vapors. These are vapors, vapors. But these vapors, due to this closed, due to this closed system, the vapors cannot comes outside. Means matter is not coming outside from the system to surroundings. Only the energy is exchanging, energy exchanging. But mass or matter not exchanging. So the system which can exchange energy only, exchange energy, but not matter or mass. Such kind of systems are called as closed system. Okay students, in closed system example, hot water in a closed vessel. For example, one steel flask you have to take, completely closed one steel bottle you have to take. In that steel bottle normally you have to keep hot water. After half an hour or 10 minutes, that hot water becomes cool. Why? But water quantity is not changed because the water vapors are not escaped from the beaker. Only hot means energy is exchanged, but matter not exchanged. Matter not exchanged. Quantity remains same, but energy is decreased. Means that energy exchanged from system to surrounding. Such type of systems are called as closed systems. Next, isolated system. Isolated means completely, like this system you are taking. Isolated means thermoflask. If you are thinking thermoflask walls are isolated. Due to that insulated walls, due to that insulated walls in thermoflask, heat means energy not exchange, means does not exchange energy, and mass does not exchange. Both energy as well as mass does not exchanges from system to surroundings. Such type of systems are called as isolated system. For example, good example for isolated system is perfectly insulated closed flask containing hot water. Means simple example, in thermoflask, hot water present in thermoflask, because the thermoflask is completely or perfectly insulated. Then energy as well as matter does not exchanges from system to surroundings. Such type of systems are called as isolated systems. Okay students, next another type of classification of system is based on the composition, means chemical composition. Based on the composition of system, based on the composition, the systems are classified into two types. One is homo, the second one is homo and hetero. Homogeneous system and heterogeneous system. Homogeneous system means the system contains only one type of components, means they have only single phase. They have only single phase. Means single phase means only one component is present. Pure solids or pure liquids. Pure solids comma or liquids. Such type of compounds are belongs to homogeneous system, or gaseous mixture also. The gaseous mixtures already while classes are discussing, that time we are discussing in offline classes. Gaseous mixture is also example for homogeneous system only. Why means the gaseous mixtures, if you are present in the atmospheric air, so many gases are present, but we cannot identify that whether this side is CO2 is there, this side is O2 is present, like that we cannot separate. That's why gaseous mixture is also belongs to homogeneous system. Heterogeneous system means the system consists of two or more than two phases. Two or more than two phases, such type of components are called as heterogeneous system. For example, in water, this is water, and in that water you have to take stones. Then the stone is insoluble in water. Then the stone and water will be separated out. Means exist in two phases. That's why it is belongs to heterogeneous system. It belongs to heterogeneous system. So based on the composition of system, the systems are classified into two types. One is homogeneous, the second one is heterogeneous. Based on the interactions between the system and surrounding, systems are classified into three types. One is open, closed, and isolated systems. Okay, students. So we are discussed completely what is system, what is surroundings, and what are the types of system and boundaries we are discussed. Let's see the next important concepts from this chapter is types of properties of system. So these two are very, very important properties. Mainly in thermodynamics, the systems has mainly contains two types of properties are present. One is extensive property, the second one is intensive property. Extensive property and intensive property. So these examples directly they are asking in NEET and JEE examination directly. So how they are asking among the following options, which is belongs to extensive property, which is belongs to intensive property, which does not belongs to intensive property, which does not belongs to extensive property. Like that questions they are asking directly from these extensive properties and intensive properties. Examples are very, very important. So and for board examination also compulsory in 2 marks question they will ask from this chapter. What kind of properties are called as extensive properties? The property of system which depends on the amount of substance, which depends on the amount of substance, means matter. It depends on the amount of substance. If substance, the quantity of the substance is increases, then the property will be either increasing or decreasing. It will be either increases or decreases. It will be changes. So the properties which are depends on the amount of the substance in a system, those are called as extensive properties. For example, mass, the quantity is increases, then the mass will be increases. So the mass is depends on the quantity. Like volume and internal energy, internal energy, enthalpy, internal energy symbol is E, and enthalpy H, and entropy S, Gibbs energy G, and heat content Q. These all number of moles small n. These all are mainly depends on the amount of substance present in the system. That's why these all are called as extensive properties. So briefly we need to discuss about what is internal energy and enthalpy, entropy, and Gibbs free energy, and relations between internal energy and enthalpy, and relations between Gibbs free energy, entropy, and enthalpy. In further classes we will discuss. And the relations are very, very important for objective examination also. That formulas and related questions compulsory they are asking in NEET and JEE examination. So extensive properties means you have to remember the properties of system depends on amount of substance or quantity of substance present in the system. If they are not dependent on the quantity of the system, means independent. If they are independent, those are called as intensive properties. Means if the quantity is less or more, the property is remains constant, remains same. Such type of properties are called as intensive properties. The such type of properties are called as intensive properties. Let's see that intensive properties examples: density, pressure, temperature, concentration, boiling points, melting points, viscosity, and surface tension. So density you have to think. For example, you have to take 1 liter of solution. Either in the same solution, you have to take 1 ml or 1 liter or 5 liters whatever the quantity if you are taking, the density remains same, and pressure as well as temperature in the system and concentration also remains same. Already you are making the one particular solution, means from that solution you have to take either 5 ml or 10 ml or 1 liter. Its concentration is same, as well as boiling points will be same, melting points will be constant. So such type of the properties which independent on the amount of substance or quantity of substance, those are called as intensive properties. Intensive properties examples: density, pressure, temperature, concentration, boiling points, melting points, viscosity, and surface tension. Okay, students. Next, different types of variables or functions. We need to discuss about what are the different types of variables are present and different types of functions in thermodynamics. It is also very, very important. So there are two types of functions or two types of variables are present. One is state functions. It is also called as state variables. State functions or state variables. State means the system which depends on initial and final states. But how the initial state is changed into final state, means it does not is independent on the changes, means it is independent. The change from one state to another state, the change is known as path. It is independent on the path but depends on initial and final state. Such type of systems are called as state functions or state variables. Let's see the definition. The thermodynamic properties of system which depends on initial and final states of the system but independent on the path. Path means what is the meaning of path? How the change is accomplished, how the changes is occurs, means how the change is happened from initial to final state, that is called a path. It is independent of the path but it that depends on initial and final state. Such type of properties or variables are known as state functions or state variables. Such type of properties are known as state functions or state variables. So almost state variable examples all are present in extensive properties only. So all extensive properties are depends on quantity and they are also depends on initial and final states. Okay, students. So main important examples for state functions or state variables: internal energy, means initial internal energy and final, and the difference in the internal energy we can calculate, and enthalpy, entropy, Gibbs energy, pressure, temperature, volume, and number of moles of a system. Those are examples for state functions or state variables. That reverse is known as a path functions or path variables. Path functions or path variables means these are the properties of the system which depends on only path but not initial and final state of the system, but not initial and final state of the system. Those are known as path functions or path variables. Heat and work. How the heat means amount of quantity of temperature is known as heat. Work, it is the form of energy, is the energy form. Those are belongs to path functions or path variables. Now, next main important thing is thermodynamic process. What are the important thermodynamic process are present? Let's see that thermodynamic process. Thermodynamic process means we are applying different conditions. If different conditions means temperature and pressure and volume, like different temperature and different pressure and different volumes we are changing, means we are applying different conditions, then that conditions, how due to that conditions how the system is changing, the system what type of changes are occurs, what type of changes are occurs present in the system, those are known as a thermodynamic process. Those are known as a thermodynamic process. So the main important thermodynamic process are isothermal process, adiabatic process, isobaric process, and isochoric process, reversible process, and irreversible process. These are the main important thermodynamical process. So we need to discuss about these all process and during this process how the energy, what kind of work, how the work is taking place, and work relation also we need to discuss. Okay, let's say that first one is Types of thermodynamical process. The first one is isothermal. Isothermal. Thermal means temperature. Iso means same. Means the temperature is constant. The process in which temperature of the system is remains constant. So, for example, this is the system. In this system, the temperature delta T is equals to constant means automatically internal energy change also constant is zero. So such type of systems are called as a isothermal process. Isothermal process. Okay. Next, adiabatic process. Adiabatic process means for example, the system. For example, you have to take any one object. That object you have to heat at constant temperature, at different temperature, and the system will absorb some amount of heat. It absorbs some amount of heat. That heat of the system is constant, means heat does not changes between the system and surroundings. Between the system and surroundings, such type of process is known as adiabatic process. In adiabatic process, Q is constant. So if Q is constant, for example, thermoflask, isolated system you have to take. This is a isolated system. This is isolated system. In this isolated system, energy as well as matter does not exchange from system to surroundings. Means Q is constant. Q is a constant. So in that type of process is known as adiabatic process. So it can be achieved insulating boundaries of the system. The system having insulated boundaries are present. Such type of process is known as adiabatic process. This type of process is known as a adiabatic process. In adiabatic process, heat is a constant. Heat cannot changing. Heat is not changing. Okay, students. Let's see next isobaric process. Isobaric process. So in isobaric process, what is isobaric process? The system in which pressure is constant, delta P is constant, is known as isobaric process. And isochoric process means volume is constant, delta V is constant. Such type of system is known as a isochoric process. So now we need to express these all systems graphically with respect to pressure and volume graph. Already in states of matter chapter, there only we are discussed isobaric process, isochoric process, and isothermal process, those all, and graphical representations also we are discussed. Once again, let's see pressure versus volume graph for isothermal. Sorry, first one isobaric process we'll see. Isobaric process means pressure is constant, delta P is equals to 0, means pressure is constant, means the line will comes parallel to the volume axis. Like this is a isobaric process. Next, isochoric process, volume is constant, means V is constant, means it is the line will comes parallel to the pressure axis. Next, isothermal process and adiabatic process are a curve. Is a just like a curve is not a straight line. Isobaric process and isochoric process are the straight lines, and isobaric process, the graph is parallel to the x-axis and or volume axis. And isochoric process, the line is parallel to the pressure axis. But isothermal and adiabatic process are the curves. And at pressure and volume, always in isothermal process, the line curve will be upside will comes when compared to adiabatic process. The adiabatic process line will comes down. So during these lines here work, this is isothermal, and this is adiabatic process. And it is Isochoric process. Isochoric process. Yes, Rani, listen carefully. So these graphs are very, very important for objective exam. JEE and NEET exam important. From these graphs, which is in the upside line, it has maximum energy, work done by the system, work done order, work done of the system order, work done by the system order. Always work in isobaric process is more than isothermal process and adiabatic process and isochoric process. It is very, very important. Next, reversible system and irreversible systems we need to discuss. What is the reversible and irreversible process? Okay, students, listen carefully. We already know that reversible reactions, like reversible reaction is nothing but reversible process only, the system. Reversible process. Reversible process, a process in which the direction may be reversed, means the direction will be changes either forward or backward at any stage by the change in the temperature, pressure, or volume of the system. If changing the temperature, pressure, or volume of the system, the direction of the process or direction of the system will be changes, means reversed. Direction of the system will be becomes reverse, front and back. Such type of process is known as a reversible process. These reversible processes are going on very slow. Why it is going on very slow? One step forward, one step backward, one step forward, one step backward, means they having driving forces, means forward forces, and opposing force backward. Both are almost equal. That's why both the directions are reversed, front and back reversions are present. So the driving forces are almost, driving force and opposing force both are almost equal and exist equilibrium state between the system and surroundings. So during this reversible process, work done by the system is maximum. Work done by the system is a maximum when compared to irreversible process. When compared to irreversible process. Okay, students, listen carefully. Irreversible process. Irreversible process means the reaction is moving in only in one direction. The reaction is moving in only one direction and cannot be reversed. Such type of process are known as a irreversible process. So mostly in naturally occurring process like flow of wind and flow of water, and those are all naturally, and transformation of temperature or heat transferred from higher temperature to lower temperature. These all are naturally occurring process. Those all naturally occurring process are irreversible process only. That is called expansion. During that expansion process, the work done by the system in reversible process, a reversible process is more when compared to irreversible process. And during this irreversible process, always driving forces are more when compared to opposing force. There is no opposing force. Opposing forces are very, very weak. That's why what happens, it always moves in single direction only. It always moves in a single direction only. That's why in which driving forces are much higher than opposing forces. Such type of process are known as irreversible